Hello world and welcome to another video, and in this video we'll learn about Numpy. So Numpy is basically used for data analysis in data science, machine learning. It is the basis of everything because in this you can find mean, median, mode, standard deviation, lots of things you could do with this. So we'll just see what Numpy is first. Okay, so Numpy, it's numerical Python, so you can do all the mathematical statistical stuff in this. So you store numerical data into this. For example, your images, videos and different data frames are stored in Numpy. So images like black and white images or color images all are stored in Numpy. Like they have some color coding, and according to that color code they are stored in arrays. Okay, we'll just check. So there are different types. So we can have 1D array, 2D array, 3D array, or any other dimension if you want to specify more. Okay. So how to store data? So data is stored in arrays. So you can see these are single square bracket over here. So this is called a 1D array. It looks similar to the Python list, but it is much more faster. Why? Because Python list is very dynamic. So it automatically guesses the type inside. But in this case, Numpy is static. It is statically typed. So that is why what happens is you already have to set the default type. And because of that default data type, it is very fast than the list, than the normal Python list. Okay, so Numpy arrays. So just imagine now, in the previous slide we saw it was a 1D array. Now we can see there are two brackets over here, or if you just simply want to know how to find what is the dimension, so just check the last brackets. So there are two square brackets, that means it is a two-dimensional array. So here we'll have only black and white pixels. So let's see. So this is the black and white image. And if we want a color image, so we have to give 3 dimensions, that is RGB. So red, green and blue pixel images. Don't worry if you are not understanding anything. This is just how the data frame looks and how the images are stored in Numpy. Okay. So this is how we'll have a color image, and this is the color coding for each and every pixel. Okay. Now how do we install Numpy? So it's very easy. We have to just open a command prompt and type pip install Numpy. So pip is Python package indexer or Python package. Like you will use pip to install any package you want, which is a third-party package. And we'll be using another editor, not VS Code, for this, because we want to visualize what we do after each and every step. So we'll be using Jupyter Notebook. I believe this is made by Microsoft. I don't really know, but I think so. So it's easy. You have to just do pip install Jupyter or pip install Jupyter Notebook. So we'll open a command prompt and we'll do this. So let's get ahead. So this is how my desktop looks. Okay, I'll just press Windows key and I'll type cmd. That is my command prompt. Okay, so this is my command prompt, and here I can write pip install Numpy. So you need an internet connection for this, and just press enter. For me, Numpy is already installed, so it will just say pre-installed or it is already installed. So now you can see it is already returned requirement already satisfied. So it is not going to install for me because Numpy package is already present. But in your case, it will install certain packages. Okay, great. So I will press the up arrow key and I'll just write Jupyter. And done. So Jupyter is also already installed. So now we'll create a new folder and then we'll begin. And I'll just create one new folder so that we all are on the same page. So new folder, and let's say machine learning basics or machine learning skills cafe. So we'll open this folder and we'll just go here and type cmd because we want to have this as a directory, base directory, and just write Jupyter. Oops. So just write Jupyter space notebook. Now it is properly installed. You can see a browser opening like this, and here you will see the notebook is empty because our directory over here, which we have already created, called as machine learning skills cafe, it is empty over here, so it won't show anything. Okay, so we'll just click on new and Python 3. So it opens a notebook for us. So your notebook might look a bit different and from me, but not an issue. I'll just tell you a few basic commands before we begin. So just rename this and we'll write it as basic1 and just do rename. Okay, so we'll just start with hello world. So you can just do print and we'll just write hello world. And how do we run this? So you can press Ctrl Enter to run this. So if I hold and press Ctrl Enter, or you can run from here also, and you can do just Ctrl Enter. So if you do Ctrl Enter, it will directly say hello world over here. Excellent. But what if I want another, like I want to run this and I want another cell also. So this thing is called a cell. So this is the input and this is the output. So I can just do Shift Enter. So as soon as I do Shift Enter, I can get this. Okay, I will zoom in a bit. Okay, let's say I say a equals 10, b equals a plus 10, and let's say I want to print b. So I can just do print b and Shift Enter. So it runs and it tells me it is 20. Okay, one more thing I can do is I can just call b. Instead of printing b, I can just say b, and if I do this, so it will say input and this is the output. So this is an interactive way to understand what is happening. So you can write all your functions over here, whatever you want. So function sum, and you take a comma b, and you can just say c equals a plus b, return c, and you can come here and do print sum, and here you can just have 10 comma 20 and do Shift Enter. So it will return 30. So you can write your functions as well and take the values over here. Okay, so I'll take one more new file and we'll start with NumPy. So before that, we'll just check our folder. So now you can see we have basic1, which is name of our this Python notebook, and there's also called as basic1. So if you check the extension carefully, it is IPYNB. So it is interactive Python notebook. So that is why it has the extension IPYNB. Okay, let's take a new file now. So we'll just go here and click on new, and let's do this. So it will again open another notebook. We can close the previous one and it will auto save. So don't worry even if you close it by mistake. So just go to file menu and I'll rename. You can have a window over here itself to rename. So I'll just do NumPy basics and it's part 1. Let's say part 1. So rename. Okay, first step is we'll just import the library. So import NumPy as np. I believe this font is visible or not. Okay, this is also visible. Okay, so we have imported NumPy as np. So first thing is we'll just create an array. So it is very easy. We can just say a, we'll just take a variable called NumPy. So we are calling NumPy as np right now. It's like a small alias name, so that we don't have to type NumPy every time. Array. So array is an inbuilt function and we can just call 1, 2, 3 and 4. So this is one of the basic array we can have, and let's call a and see what happens and how it looks. So Shift Enter. So it will show a star mark over here. That means it is importing NumPy library. So it will happen only once, so don't worry. So it says okay, it belongs to array and there's a one-dimensional array. So we'll understand how that happens. So let's say one more thing we'll do. We can just write a dot ndim. So this is to check the dimensions. Okay, what I would do is I just mark some comments as well. Dimensions and Shift Enter. So it will say it belongs to, like, it has only one dimension. If I want to check the shape, so I'll write shape. Okay, I can just write a dot shape, Shift Enter. So it says it has 4 columns. So it is saying 4 comma. Okay, when we'll have a 2D array, we'll understand this in much more detail. We can also have type of a. So where does it belong? So it belongs to the n-dimensional array of NumPy library. Okay, we can also have one more thing called as size, a dot size. So it has 4. So we can say it has 4 things in it. So I'll just write size. Okay, we'll create another array which is a 2-dimensional array. So let's create it. So b, and we'll just say np dot array, and we'll have 2 dimensions. So we'll have 2 square brackets over here. So I will just say 1, 2, 3, and one more dimension, 4. I'll just take some basic examples so it's easy to understand. And one more dimension over here, 7, 8, 9. I'll just give comma. Okay. So now I know, like, at the end there are 2 square brackets, so that means it is 2-dimensional array. We'll check this also. So let's print b. So this is how it looks. So it has 2 dimensions. That means it has 3 rows over here and 3 columns, but it is a 2-dimensional array. So let's see the dimensions. B dot ndim. We've already seen this code above. Let's check. Okay, so it has 2 dimensions. Let's see the shape as well. So b dot shape. So it is 3 by 3. Like I said, it is a 3 by 3 matrix. Okay, and yeah, let's say b dot size. So it has 9 items in it totally. So it will just say 9. Here we got 4 because it had had 4 items in it. Okay. So let's go few more ahead. Okay, let's say you want to create a matrix full of zeros. So let's say zeros equals np dot zeros, and how many zeros do you want? Let's say 5. And if I can call back zeros again. Okay, so this is all in float. That means it is decimal numbers. If I want this to be, let's say, normal integers, I can just give a data type over here, and I can define some data type, whatever I want. So let's say I want it to be np dot int, or just int. Okay, int 32-bit. Okay, let's see. So it gets converted to int. I can even use smaller memory. Don't worry if you don't understand this. Okay, so it gives us this. So by default it is 32, I believe. Okay, right. So if you don't know certain codes, you can just check the documentation, or you can use the help function. If you just want numpy dot zeros question mark. So it tells you each and every detail about that thing. So it has shape, it has data type, by default it is float, and it has order of C. That means it is like it belongs to the language C or F. F is for Fortran and C is for C programming language. Okay, so I'll just close this. If you don't understand any code, let's say nd.array, so you can just have that also. So you can also understand what are the default parameters in it. So dot array, and just give a question mark. So it is help function. So it takes object, it takes the data type, it has true, copy as true, order as k, subawk as false, and dimension also you can specify over here. Okay, so you can try those things out. Let's say I want this same code over here. So I can just write zeros, but this time I don't want it to be 1-dimensional. I want many more things, like I want it to be 3 by 3. So let's say 3 by 3, and I'll call this. Oops, oh, I forgot one more tuple. Okay. So yeah, again and again you can specify the data type. Data type is, let's say, np dot int 32, and run this. Okay, so it is all 0 0 zeros. Similarly you can have for ones, all ones. So I can just copy the same code, copy, and instead of this I can just write ones and run. Oh, I did not call. Okay, ones and run. So I'll have everything as ones. Similarly you can have ice or MTO as well. So you can, we'll just try ice. So let's say test np dot ice, let's say 3, 3, or if you want 4, 4, and 7 test. Let's see, numpy has no attribute called iso. Tuple cannot be. Okay, so whenever you have some error like this, you can just come here and just do this np.i, and we can just run this and check question mark. So it takes n, it takes m. So n is the integer, m is the optional integer, k is the integer as well, which is 0. Data type is float, order is C. Okay, so let's try this out. Let's say we want only 7. What does it give? Okay, so it gives us a 7 by 7 matrix, everything. So I, what does an I mean? So it will have all the diagonals. So this 1, 1, 1, 1, 1. So all the diagonals will be 1, and rest all the values will be 0. So let's take a smaller one. So like this. And inside this also you can specify the data type. And data type is np.int 32. So we'll have 1, 0, 0, 1. So the diagonals will only be 1, and rest everything will be zeros. Okay, so there is a good feature to search if you get stuck somewhere. Okay, nice. So now what we'll do is we'll use one more feature called as arange or array range. Array range, in short called as arange. Okay, so we'll just do, if you quickly want to create some good array, so you can just do this. Let's say a equals np.arange, and I want to just write 20 and call a. So it will create an array of 0 to 19. That means it has all the 20 elements starting from 0 to 19. Okay, so arange also takes step and stop and start. So you can have b equals np.arange. It starts, let us start from 2, we'll go up to 21, and we'll have a step of 2. So if you don't know, this is simple list logic, and we'll just call b. So it will start from 2, it will go up to 21, but it won't include 21 with a step of 2. So it will skip 1 and take the another one. So if I give 3, so in this example I will have 2, 4, 6, 8, all the even numbers. If I take 3 and run this, so this will be 2 plus 3, 5 plus 3, 8, and it will go up till 20. Okay, excellent. So we are getting these. Similarly, you can have called as linearly spaced matrices. So I'll just write that, linearly spaced matrix. These are simple matrices. Okay, so in this case what will happen is it will create a linear space. For example, let's say linear np.linear space, and let's say we want to start at 2, we want to go up to let's say 10, and we want 5 numbers. So what it will do is it will evenly distribute everything. Let's do, like, I'll just show it to you. So it will distribute evenly between 2 to 10 all the numbers, like 5 numbers we want. So 2, 4, 6, 8, 10. So it will automatically decide how much difference it should use. So if I give 10, so it will start with 2, 2.88, 3.77, and similarly it will go till 10. Okay, I could have used another number also, 8 or something. So it will make 8 numbers which are linearly spaced with each other. I believe you're understanding this. So what's we'll concatenate two different so concatenation, two different arrays will concatenate together. Concatenation. Okay, so let's say a equals, very simple, np dot array. It starts from it has an array of, let's say, 1 2 3 4. We're just trying to understand the maths behind this. So once we get this all done, you'll understand why we are doing this once we start with machine learning or data science course. Okay, so np dot, we can just have linear space or arange. Okay, and arange, let's say I want 4. Okay, and I can just have, now I can have 4 elements in each, so I can start with 4 and go up to 8. Okay, so now I can have C as concatenation of these two. So np dot concatenate, what do I want to concatenate? These two matrices. Okay, and let's call C. Oops, only integer scalar arrays can be converted into something missing. Okay, so I missed the scalar thing over here. Oh, not an issue. So we just have to pass these two also in and tuple, in the tuple, and it will like just add these two together. Okay, so this was quite the basics, and we'll just understand indexing also. So we'll take another 2-dimensional array and we'll try to understand the how indexing is done. So indexing and splicing or slicing. Okay, so let's say 2D array. So 2D. First we'll do 1D so that you understand well. So we already have 1D array. We'll just create new one. np dot arange. I'll start it from 1. We'll go up to 11 with equal spacing. So let's print 1D. So we have all these elements. So similar to our list, we can just do 1D and we can index. Let's say I want to have second indexing. So this is, I'll get 3 because the 0 indexing is 1. So 0 index value is 1 and first index is 2, and similarly it will go on. So if I run this, so it will give me 3, or it will fetch me 3. You can also do one more trick, which is D, and you can say where 1D is greater than 5. Let's do this and check. So it will give everything which is greater than 5. So 6, 7, 8, 9. So you can even use booleans and operators just to index and splice. We can also use the range method. So we can just do this also 1D, and here we can say let's start with 2 and go up to 6. So we'll have 3, 4, 5, 6. Okay, let's take quickly a 2-dimensional array. So 2D, and let's have np dot array, and let's create a 2-dimensional array. So because it is 2-dimensional, I need 2 square brackets. So I'll again just take very simple example for again this. So 5, 6, 7, 8, and just give quickly commas. Oops. Okay, so 9, 10, 11, 12. Okay, I'm just making it 4 by 4. It's a bit complex. Not at all. Okay, so let's check how it looks. So again, you can run all the basic codes like n-dimensional and shape and size and everything. For now, I'll just omit that. Okay, so just remember, this is the row and these are the columns. Okay, so if I want to index it, how will I do it? So 2D. Okay, now you have to guess this. Let's say I want okay, I'll start with this easy example. So I want 1. I want only this character or this element to be printed. So I can write the element which is printed in the 0th row and in the 0th column. Okay, so if I run this now, I'll get 1. I believe you understood. So it belongs to 0th row and 0th column. Okay, so now tell me about what if I want 10. So tell me. Okay, I cannot hear you, but still tell me. So it belongs to the 0, 1, 2. So it belongs to the second row. Okay, and which column? 0, 1. So it belongs to the first column. Okay, so I get 10. So okay, this is the easiest one. 16. Quick. 2D, and yeah. So it is belongs to 0, 1, 2, 3. So third row and 0, 1, 2, 3. Third column. So 3, 3. Okay, so if you don't know how this indexing is being done, that means you haven't checked the list video yet. So first try and understand what are list. We already have that video, so just check that out first and later on come to this, so you'll understand how this indexing is done. Now splicing. I've already written this, but why am I writing splicing? Slicing of 2D. Okay, so now I want okay, just try to understand this code. You first tell me what we are going to get. Okay, so I'll start with 0 to 2 comma 1 to 3. Okay, so what have I written this and what am I going to get? So 0 to 2 means these two rows. So this belongs to, like, before the comma it belongs to rows, like we have understood over here. Everything belongs to row. Okay, I'll just write it over here. Hashtag name, and this is the row and this is the column. Okay, so I've written this, so we'll apply the same logic here. So this is the row and this is the column. Okay, so I'm starting from 0 to 2, so I'll have the first row and the second row, and I'll stop at the second row because the index is 2. Okay, so I'm having these two rows, and what columns? 1 and 3. So this is the 0 column, so I won't be taking this, but this is the second column and this is the third column, and I'm stopping at the third, fourth. That means over here I'm stopping. So I'll have 2, 3, 6, 7 as my answer. Okay, let's check. Okay, excellent. So I believe you understood this. If not, we'll do this again. Okay, I printed this and again I'll type. Okay, so again I'll just tell you, if I want last two rows, okay, completely last two rows, so I will just write, so I want last two rows, so index is 0, 1, 2. So 2 till the end I want everything, so I will leave it as blank, and again I want everything, so I'll just give blank over here. Okay, so I'll get last two rows. If I want last two columns, so what should be the code? Chalo. So last two columns like this, I want it. Last two columns. So what should be the code? Just tell me. So I want these rows together, so I'll write just this because I want all the rows, but I'm just making changes in the, I'm being choosy at the columns part, so I'll just write second column to everything. So I'll have everything 3, 4 like this. Okay, just tell me I want 6, 7, 8, 10, 11, 12, 14, 15, 16. Okay, or I want 6 to 12. Okay, chalo. What am I supposed to write? What should be our code? 6 to 12. Okay, think if you're thinking. So I want all the rows, so I'm not being choosy over there, so I'll write everything, and I want this. Okay, now I'm being choosy over here at rows also. I'm not taking the first one, so I'll be taking first and everything from the first. So I don't want this row. Oops, I don't want this row, so I'll just skip that and I'll start from the first index, which is here. So I want these two. I'll go from here till the third index, and I want these three. So I'll start from first index to everything. So I believe you're understanding how indexing works. If not, just practice more, and I believe we'll stop here and go for further more advanced codes in the next lecture, or in the next video. Sorry, I keep saying lecture. Okay, so see you soon. Do like, share, subscribe the channel, and share as much as possible to support us. Thank you so much and see you soon.